Forgive me for the camera angle. I will show it again. But I am going to be working on assignment 2, which is problems 169, 170, 171, and 172 on unit 3.4, which is motion in space. Okay, so the prompt is, given that r of t equals vector of e to the negative 5t sine t for your cosine area, and then e to the negative 5t cosine t. Oh no, sorry, not cosine. That's going to be your I, and then e to the negative 5t cosine t is going to be your j, as well as the last one being 4 to the e of negative 5t is going to be your k. Just want to write that out for you. So r of t is equal to 4 e to the negative 5t sine t, e to the negative 5t cosine t, and then 4e to the negative 5t. Sure, you can see that? Okay. Then is the position vector of a moving particle. Find the following quantities. Okay. So 169 is asking for the velocity of the particles. Okay. So let's go ahead and start with that. So the general formula, I guess, for the velocity is is pretty much the derivative of the position vector, which will give you v of t is equal to r prime of t. Okay, see that? So pretty much you would differentiate each part. So you would start off with product rule. So first off, I would do d of t for the side, which is going to be e of negative 5t sine t. So what I like to do is I like to break each part separately and then work on it individually so that it doesn't look too crowded. So that would give you pretty much, I would say the same. So this would come down. So it'd be negative 5 e to the negative 5t, and then obviously sine t, you got to bring that over, sine t plus, and then now the derivative of this whole area now, which is going to be e to the negative 5t, because e pretty much is the same, and then cosine t. And then, so now you would just factor out the e to the negative 5t. So that would go e to the negative 5t, which is cosine t minus 5 sine t. Let me fix my 5 for you guys. So that would give you this part. Okay, now for the second part, I would use product rule again. So that would give me d of t, which is, now this one I am going to put the j function in there. That's what I'm referring to. So I is going to be j, and this is going to be k. So if I'm ever blurting out those letters, that's what I'm referring to. So it's going to be e to the negative 5t cosine of t. Okay, so now you pretty much split it apart and you do it all over again. So that would come down to negative 5e to negative 5t, and then how you would pretty much close that. Now you bring the cosine t over, and then now you would take the derivative of that, so that'd be e to the negative 5t, and derivative of cosine is negative sine t, and then same thing, you would factor it out. The e again, the e function, which can equal lower e to the negative 5t, so negative 5 cosine t minus sine t, and that's that. And now you just do the same thing for k, which is going to be d of t, that's 4e to the negative 5t, and then pretty much all you're doing is multiplying that over. Negative 4 or positive 4 times negative 5 is 20. Not too hard, you don't need a calculator for that. So it'll be 20 e to the, and then that pretty much is the same, which is negative 5t. Okay, so your final velocity would be v of t. You pretty much just grab your answers from all these. So this one was right here, and then this one was right here. So then e to the negative 5t, and then remember we factor them out, so it'd be cosine t minus 5 sine t, and then close that, which is now the j, so the e to the negative 5t, negative 5 cosine t minus sine t, and then close that, and then parentheses. I don't have enough room right here, so I'm gonna continue it on the bottom row. That's be negative 20 e to the negative 5t, and then close that. So then this will be your whole answer for the final velocity of the particles. Now 170 is asking find the speed of the particles. So 170 is find the speed of the particles. Okay. It's gonna be the same equation from before. So if I remember correctly, the formula was absolute value v of t equals square root v squared of x plus v squared of y plus v squared of z, because you have your 3D plane. Okay, now you would just substitute let me do that for you guys. I, j, and k. Just substitute those in, meaning we equal into e to the negative 10 t and then also, sorry, I didn't mention previously, the reason why I turned this to a 10 was because originally it was a 5 over here, but you have to multiply the second power, so that puts it to 10. Just so that you're not too confused. T minus 5 sine t squared plus e to the negative 10 t negative 5 cosine t minus sine t squared. And then let me just do this. And then continue it on the bottom row because I don't have enough room. Plus 400 e to negative 10 t. And then the reason why I did that 400 because 20 to the second power is 400 if I remember correctly. Let me just show you guys that to confirm it. So that's going to be 20 to the second power, which is 400. So that's how I got this number right here. And then I'm just gonna continue the square root and end it off right here, so that you can see that. And now what I do is I factor out the e to the 10, since it's pretty much a common root to all these. E to the negative 5t, because that's that. And then it's gonna be cosine of t minus 5 sine of t squared plus negative 5, sorry, cosine. Negative 5 cosine of t minus sine of t squared plus 400. Do that. Now you pretty much simplify it and then expand it out. So this drops down to either two of these. So it'd be cosine of negative 5 sine squared equals cosine squared minus 10 sine cosine, because you have to multiply them in, plus 25 sine squared. And then you have the and then you expand that one out. This will be negative 5 cosine minus sine squared, which equals, expand that one out, which is oh, sorry, I don't think you know what I'm doing right here. Okay, so what I'm doing is I'm doing I call it the bird method. That's just how I was showing it. So cosine minus 5 sine, that's that, and then cosine minus 5 sine, and then what I'm doing is I'm just factoring over, and that's how I got this answer. Same thing over here, I'm just doing the same thing over here. So this would be negative 5 cosine minus sine, and then negative 5 cosine minus sine. Okay, so that's that. So that'll give you negative 5 cosine minus, or times negative 5 cosine. That's gonna be 25 cosine squared plus, and then now negative 5 cosine times negative sine cosine, negative sine, sorry, is plus 10 sine cosine, and then plus, because you have a negative times negative, which is sine squared. Sine squared. Now you would just cancel them out. So this one cancels out with this one, and then it's really it. Yeah, that's kind of really it. Now you just combine like terms. Sorry, let me just move this over. Combine like terms. So 25 cosine squared plus cosine squared, which is both positive, so that's 26 cosine squared plus 25 sine squared plus sine squared, which is 26 sine squared, and then that's going to equal the sorry, the I'm gonna do square root of that. Just equal 26. Okay, sorry. I'll show you how to work this. Go on the next page so I run out of room. So if I remember correctly, I have 26 cosine squared plus 26 sine squared equals 26. And then, so pretty much all you do is you just plug it back into the original, which was absolute value of v, e to the negative 5t, because remember that was something we factored out, so we kept it out. And then drops down to 26, because that equals 26. Because this is 1, this is 1. So then, yeah, it's 26, and then you have to bring back the 400 that we had earlier. And then if you add those, it's 426. Keep the radical sign, bring down the e to the negative 5t equals v as value. And then that would be your answer. So vt equals e to the negative 5t radical 426 would be your answer. Well, that'd be your answer for the speed. Now it's time to find the 171 was find the acceleration of the particle. Find the acceleration. So the equation for that was acceleration, pretty much you have to take the derivative of the velocity. So acceleration, when you use a of t equals the derivative of velocity, which is the v prime t. Now what you would start off with doing is you would like I said earlier, I like to break down each part, so you would differentiate first. And I personally like to use product rule on this stuff. So I would start off with e to the negative 5t. And the original was cosine t minus 5 sine t, because that was originally over here. Sorry, I don't think you know which one I'm referring to. This one. Okay. So I would take the derivative of the, let me close this, of the 5e, so negative 5e. Sorry, no. Let me explain. So I take the derivative of this, which should be take the derivative of this, you factor out negative 5e to negative 5t, and then and then you would take the derivative of the inside function, which was cosine negative 5 sine dx equal to negative sine minus 5 cosine. Get that. So pretty much you plug that back in, which is I'm using back acceleration equals negative 5e to the negative 5t. Okay, so the way I got this was I pretty much took the derivative of this. The n subject comes forward, and then e's product stays the same. So that's why I did the negative 5e to negative 5t, because it stayed the same. Okay, so going back to this, and then you have the cosine negative 5 sine, and then you would do that for, now you're using the, sorry, I lost my place. This one. Now you use j. Plus e to negative 5t sine minus 5 cosine, which was j. And then I have to factor it out, which would equal e to the negative 5t. Same thing, we're always factoring those out. And now you have to factor them in, which is 24 sine t minus 10 cosine of t. Yeah. And then now you have to do the same thing for pretty much the other ones. So you do it all over again. So we e to the negative 5t, which was negative 5 cosine minus sine, which was the j that I was mentioning earlier. Negative 5 cosine minus sine. Now you differentiate the inside, which is 5 sine minus cosine. And then you would use product rule. I'm not going to reuse the, because this is j, it's now going to be the y, which is a of y equals negative, same thing moving over, 5e to the negative 5t. And then bring this down. You bring the original one down, which was negative 5 cosine minus sine, plus now what we got, which was e to the negative 5t. And that's 5 sine minus cosine, which was the derivative of the inside function. And then you pretty much simplify that, which comes down to e to the, simplify that down, so the 5 cancels out, which is e to the negative 5t. And then you're distributing, combining the terms, which comes out the same, 24 cosine. It's pretty much the same, except flipped is what I got whenever I had practiced it. So over here we had the 24 cosine t, and then over here we had the negative 10 cosine t, and over here we had 10 cosine, or 10 sine t, and over here we had 24 sine t. So it was just the values got switched, is what I noticed. But now we're doing the same thing for k, or the z value, which was d of t. I'm pretty sure that was the, sorry, I have to flip back. Negative 20 e to the 5t. Negative 20 e to the negative 5t, which do that. So it comes down to negative 20 times negative 5, which is 100. 100, and then the derivative of e is always the same, e negative 5t. So that would be your k, or your z, and then now you're getting everything. So the final acceleration, so you bring everything back together, pretty much. So final acceleration will be a of t equals, and then you get the first one, which was e to the 5t, negative 5t, within 24 sine t minus 10 cosine t, and now the y, which is this one, which is this one right here, which is e to negative 5t, 24 cosine t plus 10 sine t, and then now you do the z, which is the one that we just did, and then which is comma 100 e to negative 5t. And that's your final acceleration. And then the last question, I'm gonna do it on another page. Sorry, let me show you guys real quick. Okay. Now the last question is asking find the maximum speed of the point of the on the circumference of an automobile tire of a radius of 1 foot when the automobile is traveling at 55 miles per hour. Okay, so what we know, 172. So what we know, the radius was 1 foot, And then the speed was 55 miles per hour. Okay. So pretty much we would like to use units that we can transfer over. So I'm going to convert the speed to something more useful, which in this case we could do feet per second because we already have feet as a unit. So what we'll do is we'll do 55 being on the outside. Let me add my units, not sure how nitpicky. Miles per hour. And then we want to do, so I had to search this up previously. So every 1 mile, it's 5,280 feet. Close that. And then now you want to convert that into, you want to get the seconds now. So every 1 hour, you have 3,600 seconds. So all you would really do is just multiply everything in. So you're multiplying this in, which is gonna be, I'm gonna type it and I'll show you guys. 55 times 5,280 over 1 multiplied by 1 over 3,600. Which is going to give you 80.6, and then you can round to 80.67 feet per second. So this is going to equal to 80.67 feet per second is what I got for the how fast the center of the tire moves up. Now you kind of got to consider everything. So I'm going to consider now rotational speed. So since the tire rolls without slipping, you got to kind of do everything. So you do, the equation I used was velocity equals radius times work, which was R, we know was 1. So what I got was, this was pretty much your W, how much work you used or whatever it was, whatever you want to call it. So what I would do is I would just put that into an equation, which, I mean, if you really think about it, it's just 1 times 80.67. So that, 80. So that turns into the same thing. So nothing really changes. So yes, your V is equal to 80.67 feet per second. Now you gotta get maximum speed. So at the top of the tire, the translation of velocity and the rotational velocity are pretty much the same because it's all going at the same momentum. It's all going to cover the same amount of distance, so it's all the same. So what I like to do is, for the maximum speed, I would calculate how speed of this is plus this. So they're all the same, so it's going to be 80.67, and that's me 80.67, and I'll pretty much add those up. So I'm gonna do max speed. So I'm gonna do 80.67 feet per second, because this is half, this is another half. So I'm gonna multiply that by 2, covering both, which is gonna be 80.67 times 2. Sorry. It's gonna be 161.34. It's gonna be 161.34 feet per second. So pretty much, if you look at this, the maximum speed is going to be 161.34 feet per second. And then if you pretty much do the same thing backwards, which was, sorry, let me do that real quick for you guys. So this would be 161 Um, so pretty much if you do it backwards, if you want to convert it back to miles per hour, I just flipped everything over. So I did 161.34 feet per second, and then change that to 1 mile over 5280 feet times 3600 seconds over 1 hour. It's gonna leave you feet and then seconds. So what that's gonna do is you multiply everything over. So I got the 161.34. You multiply, sorry, I did this backwards on my calculator, but it still gives you the same answer. So you multiply by the 3600, which is over 1, so it's 3600, and then you're dividing by the 5280, which are divided by 5280, and you get 110 flats. So that's going to equal 110 miles, because you get miles per hour. So that's the equivalent, or you can keep it in feet per second. So those two are your answers. Thank you very much for your time.